Alright, thanks for tuning in to the last one of the series here, areas of trapezoids, rhombuses, and kites. So in lesson 6.5 we learned that the bases of a trapezoid are the parallel sides and the legs are the non-parallel sides. So you can see that the bases are parallel, the legs are non-parallel. The height is going to be the perpendicular distance between the two bases. Alright, so the area of this trapezoid, the area is going to be equal to 1/2 times the height times base 1 plus base 2. So let's go ahead and use this. Approximate the area of Arkansas by finding the area of the trapezoid shown. Okay, so we have Arkansas. It looks like a trapezoid. Base 1 is 250, base 2 is 190. So my area here is going to be 1/2 the height, that's this perpendicular distance between the two bases, that's 242. And then we'll do base 1 plus base 2, plug in values there. And then I put this in the calculator. So the area, approximate area of Arkansas is about 53,240 miles squared. It's pretty big. Alright. Properties of special right triangles can help you find the area of a trapezoid. We're going to find the area using a right triangle. So we have base 1 and base 2. So we have base 1 and we have base 2 here. We don't know what the height is. However, we know that this is a 60-degree angle. And we can use a special right triangle of 30, 60, 90 to get this height. So what did they do here? So what they did is, this is 7. I can find this distance if I took 7 minus 5, because that cuts that off, makes that a nice rectangle. So this shorter leg is equal to 2. And I know that my longer leg is equal to the shorter leg times root 3. So my longer leg is equal to 2 root 3. So that's my height. So my area is going to equal to 1/2 times 2 root 3 times 12, which is, they want it in simple radical form. That'll be 12 root 3 meters squared. Okay, just a sec. Going right along here. Here we have a rhombus and a kite. So rhombuses and kites have perpendicular diagonals. This property allows you to find areas using the following theorem. The area of a rhombus or a kite is equal to 1/2 diagonal 1 times diagonal 2. They provide a visual proof. You can read that for your own pleasure. I'm going to go into the first example, how to use this theorem. So I have two diagonals. Remember, a diagonal connects opposite vertices. So we're going to find the area of this kite. So I have a diagonal ln. So let's just say area is equal to 1/2 ln times km. ln is equal to 3 plus 3, so that's 6. km is 2 plus 5, so that's 7. So my area is going to equal 1/2 times 6 times 7. So that's 1/2 times 42. Area is equal to 21 meters squared. The fact that diagonals of a rhombus bisect each other can help you find the area. We want to find the area of the rhombus here. Okay, so the diagonals are bisecting each other. of a rhombus, that means that they cut each other in half. So what we're going to do here is we're going to use the fact that BEC is a right triangle. We're going to use the Pythagorean Theorem to solve for BE. So BE is equal to, I'm going to say BE squared plus EC squared, which is 12 squared, equals BC squared, so that's 15 squared. If you do the math, BE is equal to 9. So this is 9. They bisect each other, so they cut each other in half. So I have area is equal to 1/2 times BD times AC. So my area is going to equal 1/2 times 18 times 24. So that's 9 times 24. 216 meters squared. Alright, that's it for the lesson part, and I'll show the tutorial in the next video.